This was a road built without people working on it. No workers with shovels, no drivers in the machines. Early in the morning, 10 big machines rolled onto a highway in China. They moved in straight lines, putting down fresh asphalt. The machines made their own choices. No one told them what to do at every step. A few people sat far away, watching on screens. They were ready to help if needed, but everything went smoothly. The machines kept working, kilometer after kilometer. It was the first time a road had been made like this in the world. Dawn on the Golden Channel. The first light of morning spread over the Beijing-Hong Kong-Macau Expressway. This road is one of the most important in China. It connects the busy cities in the north to the huge industrial areas in the south. Every day, countless trucks, buses, and cars pass through, carrying goods and people across the country. But this road also has a history of problems. In 2015, during the National Day holiday, traffic here became a nightmare. At one toll station, 50 lanes of cars narrowed into just 20. The jam stretched for miles. Drivers sat still for hours, unable to move. The media called it Carmageddon. It was a clear sign that the country's roads needed to be built and maintained more efficiently. Now, years later, a very different scene was unfolding. There were no crowds of workers, no noisy shouting or hand signals. Instead, 10 massive machines stood ready. They were powered by artificial intelligence and designed to work together without human drivers. Their task was to lay 157 kilometers of fresh highway. The air was cool, but the engines hummed with quiet strength. Each machine moved into place with smooth, steady motions, lining up perfectly. No one on the ground gave orders. No one waved them forward. They were guided by their systems, ready to begin. This was not just another repair project. It was a test, a demonstration of a new way to build. As the sun climbed higher, the world's first semi-autonomous highway paving operation was about to begin. The lead machine and formation. At the front of the line was the largest machine of them all. It was wide, heavy, and built for one purpose: to lay down a perfect stretch of road in a single pass. Its metal screed spreads the hot asphalt evenly across all 4 lanes at once. The surface behind it looked smooth and black, ready for the next stage. Following closely were the rollers. They came in groups, each one with a specific job. The first group pressed the asphalt firmly, locking it into place. The next group used heavier rollers to make it even stronger. The final group used rubber wheels to finish the surface, making it tight and level from one side to the other. All the machines moved in a careful formation, keeping the same distance from each other. They didn't rush. They didn't slow down without reason. Every move was part of a plan, and every part of the plan worked without a word spoken between them. The teamwork was not human, but it was flawless. Each machine knew its role, and each one followed the lead of the giant at the front. Together, they formed a moving chain of precision. Intelligence at work. These machines were not just following a set path. They could think and react on their own. Inside each one was an advanced computer system that made choices in real time. They could sense the road, measure the surface, and change their work instantly if something was not right. They were guided by China's satellite navigation system, which could pinpoint their position within a few centimeters. This meant the machines could place every layer of asphalt exactly where it was needed. If the ground was uneven, the lead paver could adjust its screed angle. If a section needed more pressure, the rollers would press harder. Every second, thousands of small decisions were made without a human telling them what to do. The machines shared information, so the whole group worked as one. A slight change at the front was matched by the rollers behind. Far away, supervisors watched on large screens. They could see every movement and every reading from the machines. They were ready to take control if something went wrong, but the work went on without problems. The road grew longer, smoother, and more perfect with each passing minute. Engineering the senses. To work without people, the machines needed to sense the world around them. Each one carried layers of technology that acted like eyes, ears, and skin. Cameras gave them a clear view of the road ahead. Radar systems could detect objects even in low light or dust. Special sensors measured the heat of the asphalt to make sure it stayed at the right temperature. Pressure sensors checked how firmly it was being pressed down. GPS receivers kept track of their position so precisely that they never drifted from their path. The machines also talked to each other through a fast communication network. If one machine detected a change, the others knew instantly. This kept the whole group working smoothly. Safety was built into every step. Invisible electronic fences stopped the machines from getting too close to anything unsafe. If a person or object entered their path, they could stop in a moment. Emergency systems could shut everything down in seconds if needed. These features meant the machines could work with great precision while keeping the site safe. It was technology acting not just as a tool, but as a guardian over the entire project. Solving old problems. One of the hardest parts of paving a road is working at the very edge. Human drivers often leave small gaps between the asphalt and the curb. Sometimes, the edge gets damaged before the road is even finished. Fixing these mistakes takes time and extra work. The new machines solved this problem. They could follow the exact line of the road with millimeter accuracy. Their systems kept them perfectly aligned from start to finish. Even at the edges, the asphalt was placed and pressed without leaving spaces or rough spots. This process was called zero-edge rolling. It meant the surface was smooth from one side of the highway to the other. There was no need for extra patching. The edges looked as clean as the center lanes. By removing these small but common mistakes, the machines made roads that would last longer and need fewer repairs. It was a quiet but important change, one that showed how smart machines could improve not only speed, but quality. The bigger picture. Building a road like this was not just about saving time, it also changed how much work was needed from people. Normally, highway projects require many workers on site, working in long shifts. With these machines, fewer people were needed. Most of the human work happened in control rooms, watching and guiding from a distance. This made the process safer. Fewer people were exposed to heavy machines, hot asphalt, and traffic. It also meant the work could continue without long breaks or changes in shifts. The machines kept a steady pace, day after day. Some worry this could mean fewer jobs for traditional road workers, but new roles are appearing. People are needed to design, program, maintain, and operate these systems. The skills are different, but human involvement is still important. By using technology in this way, roads could be built faster, last longer, and cost less. For a country as large as China, this could mean huge savings and better connections between cities. It was more than just a smarter way to pave. It was a step toward a new way of building. Global ripples. News of the project spread quickly. Other countries began to take notice. In Europe, engineers wanted to study how China had made it work. In Japan, planners started developing their systems for future projects. Even in the United States, researchers began looking into similar ideas, despite tensions between the two nations. This was becoming more than a local achievement. It was part of a larger race to see who could lead in building autonomous infrastructure. Countries understood that whoever mastered this technology could build faster, cheaper, and of better quality. The timing was important. Many nations face growing needs for new roads, bridges, and tunnels. At the same time, fewer people are willing or able to work in dangerous construction jobs. Machines that can do this work safely and efficiently could solve both problems. China has taken the first big step. Now the rest of the world was deciding how to follow. The road ahead. This project was only the beginning. Engineers are already working on machines that can build more than highways. They are testing robots that can put up bridges, dig tunnels, and even assemble buildings. In the future, roads might be able to repair themselves. Sensors could find cracks or damage and send small machines to fix them before they grow worse. In remote areas, machines could build new routes without needing large crews to travel there. After natural disasters, emergency roads could be made quickly without putting people in danger. These ideas may sound like science fiction, but so did a road built entirely by machines. Now it has happened. The success of this project showed that the technology works. Each new project will teach the machines more, making them faster and more skilled. We may be moving toward a time when much of the world's infrastructure is built with little human labor. The question is no longer if it can be done, but how far it will go. The 157 kilometers of road made by these machines was more than a construction job. It was a sign of change. For thousands of years, building roads meant long hours of human labor. Now, machines can take on that role with speed and precision we could not match. The 10 machines from this project have already moved on to their next job. Each road they build will make them smarter. One day, we might see cities, bridges, and highways rise without a single worker on site. The world is watching, and the future is already on the move.